Hello everybody, and welcome to a screencast about understanding destructuring in Clojure. I've noticed that quite a few beginners struggle with the concept of destructuring, and I think it's partly because it's a novel concept. If you're not coming from another programming language that supports it, it can be quite difficult to wrap your head around exactly what it is and why you would need it. So I thought I'd begin by giving quite a simple definition of what destructuring is. So destructuring is a concise way to bind names to the elements of a data structure. And that's it, that's all it does. It's all about being concise and about binding names. But instead of sticking in the more academic world of words, let's hop straight in and give some examples to hopefully clear this up for you. So what is destructuring? Let's give an example. So the first thing we're going to do is we're going to create a data structure that we're going to want to destructure. So let's just do a def and let's give it a name, something like, let's define a simple, let's say some 3D coordinates, let's say. So let's call it chords, and it's 3D, so we've got, say, 10, 20, 30. So we've got an X, a Y, and a Z coordinate. So we've defined that, okay, that's fine. And now if we wanted to give those the names that I mentioned, X, Y, and Z, if we didn't know about destructuring, the first tool we'd probably reach for is a let binding. So we could say let, and then we could say, okay, let X equal the first of the chords, let Y equal the second of chords, and let Z equal the last of chords. If we run that, okay, then we haven't got anything, but let's do something with it. Let's just say add them all together, so we should get 50, 60. Yeah, and we get 60. So we've bound names X, Y, and Z to these elements in the data structure. We've described which element we want to bind it to. But this is quite a verbose way of doing it. It's perfectly fine and it's perfectly valid Clojure code, but what destructuring allows us to do is to do that in a much more concise and succinct way. So let's see how that might look. So again, let's do a let, but instead of just giving one name, what we'll do is we'll describe the shape of the data that we're trying to extract, which in this case is a vector, and then we just say X, Y, and Z, and then we pass in the actual vector chords. And then if we do plus, if I can type X, Y, and Z and run that, we should get the same result, 60. And you see how much less code it is. So let's see what's happened here. So what I mean by we've described the shape, if you look at the shape of this, the structure binding that we've done here, where it says X, Y, and Z, you see it's exactly the same shape of the data structure that we're passing in. And all we've done is we've replaced the element's value with the name that we want to give it. I think another reason that people get put off destructuring when they're first learning Clojure is that it's an extra set of brackets here. You see, oh no, even more brackets. But when you think about it, it's actually a really nice way of describing the shape of the data structure and just quickly giving them names and then allowing you to do what you want with them. So now those names are bound in exactly the same way as this. So it's not an additional functionality. It's not allowing you to do something that a standard let bind doesn't. What it is doing, though, is making it much more concise. Okay, so that's a really basic example, but so that's what destructuring is. But let's think a little bit more about some different ways that we could use it. So again, let's define a new data structure. And I should mention as well that there are two types of destructuring supported in Clojure, and this one that I've shown you here is called vector destructuring. But vector destructuring, the name is actually a bit misleading, although it's not in a way, because you use a vector to tell the compiler that that's what you want, but it actually works on any kind of sequential data structure. So what we're going to do here is we're going to define a list. Let's call it my list. And this is a standard list data structure instead of a vector. And we'll put 3 strings in there. What should we, let's pick some characters. Bron, hound, and mountain. Okay, so now we've got a list with 3 names in it. And here we should be able to do exactly the same thing that we did before. So let's bind name 1 to the first name in the list, name 2 to the second name, and name 3 to the third name. Let's just pass in that list, my list. Okay, and then what we're going to do with them, let's just do something silly, like let's reverse them by doing a string of name 3 with name2. This isn't how you would actually do a reverse, but it's just an example so you can see what's happening. So we bind the names Bron, Hound, and Mountain, name1, name2, name3, and then we just do a string where we reverse them and put name3 first. So Mountain comes first, then Hound, then Bron. Okay, and you see it worked just as well, even though it wasn't actually a vector and it's called vector destructuring. It works on any kind of sequential data structure, which means it can also work on a string, for example. Let's just show you how that would look. So let's just have a string. We've defined a string, and then let's do a let, and we can do char1, char2, char3 on our string, my string. There it is. And what should we do there? Let's just put them back together as a string. Char1. Let's just do char1 and char3. So we just grab those two. Let requires an even number. Aha, yeah. So of course. So what happened there was I didn't put the extra set of brackets, so I wasn't defining the shape of the string. So we run that, and then we've gotten rid of the second char. And this brings up another interesting feature of destructuring in Clojure, is that if there's something that you don't care about, in this case we didn't care about the second character, but we still gave it a name. But that can actually be quite confusing to someone reading your code, because you see something's given a name and then it's not used anywhere. So what you can do is replace that with an underscore, and this code should work the same way, and it does. And what this underscore tells you is, ignore this. This isn't important. We don't need to care about it. These are the two names that I want to give, and it's bound to the first position. Ignore the second position and the third position. Okay, what else can we think about? There's another cool thing that you can do with let binding. And this is something that you might be thinking of already if you're wondering, well, how would it work if I want to refer to the entire version of my string? I've kind of lost that here. All I now have names for are the individual characters. But so let's go back to our list even. So let's say that we just want to grab name2, but we also want to, let's grab name3 as well. But we also want to grab the whole list and give that a name, and we could say as cell swords. And then we need to pass it the actual list, my list. Okay, and then what should we do with that? Let's just output what cell swords is. Okay, so what's happening here? So we're ignoring the first element in the list, my list. We're binding the second element, Hound, to name2, binding the third, Mountain, to name3, and then we're naming the entire data structure that we're passing in this case, this my list, as cell swords. And in the code, I didn't actually do anything with name2 and name3. So maybe, this wouldn't actually make sense. You probably wouldn't do the destructuring in this way. But let's say if we wanted to have a vector that had both name2 and cell swords in it. So that way, and even name3 otherwise, or no, let's just say we don't care about name3. Okay, so what we've done is we've plopped out the second element in the list, Hound, and then we've also reported the entire original list as well. So that's a very useful feature that I'm sure you'll be using quite a lot with destructuring. There's a couple more features that I wanted to show you as well. Let's do the double brackets this time. So let's grab the first name out of there, and then there's a feature called and, or ampersand, as that character is actually called, and then you can give that a name. And what this says is grab the first element out and give it name1, and then any additional elements, put them all together in one symbol that we're calling more. So if we let me show you how that might look. So if we let's just output more in this case and run that. So you see what it's done is more is bound to both the rest of the list, as it were. So we could call this rest even. No, that's not a good name, because rest is a core function, but more is good enough. So that's also useful and that gets used quite commonly when you're talking about passing arguments in from a command line. This is very useful because, of course, in that situation you don't know how many arguments they're going to pass in, and that's why it's useful to have this and more. And it works just as well in Destructuring too. Okay, so that's quite a bit about vector destructuring, which, as I said, works on any kind of sequences, and any data structure where the nth function works on is a sequence, and that kind of destructuring will work. But there's also this map destructuring. So let's destructuring. So let's just call this vector destructuring. So what does map destructuring look like? Well, perhaps unsurprisingly, let's define a map. Perhaps unsurprisingly, it works on map data structures. So let's just have a simple map. Well, let's copy what we had in the original coordinates, but this time make it a map. So we've got x as 10, y as 20, and z was 30, wasn't it? So now we have a map with 3 key value pairs. So how would we get at those? So let's do a let binding again, and then this time, instead of doing the square brackets like before, what we're saying this time is now we're going to do curly brackets because we have a map data structure. So what you see is that the way you're describing the shape of the destructuring is describing the type of data structure that you have. So what we can do is, okay, so let's grab x and put it in a variable called x. Let's grab the y and put it in a variable called y, and grab the z and do that from my map. And then we should be able to just add those up like we did before, x, y, and z, 60, and that works. And you see that you put the name first, the same way you do when you're binding. So you put the name first and then the keyword. But one thing you might have noticed is that, well, this is quite verbose, because isn't there some way that Clojure could help us? Because if we're giving this another name, if we wanted to call this Bob, then of course Clojure can't possibly know that Bob and X are related, so we have to do it this way. So that would still work. But Bob isn't a very sensible name for that. And normally when you have a keyword, you've thought about the name of the keyword and you've given it a sensible name. And we can actually make use of that by doing a little trick, which is called keys. So you say to Clojure, use the keys from this map as the names of the bindings that I'm going to be using. So you can just say keys x, y, and z, and it will just grab, it will convert these into keywords and look them up in the map basically. So if we do my map, and again we do plus x, y, and z, just to see that that should be exactly the same, 60. Yeah, so that's worked in exactly the same way as doing this. And in this case, it doesn't actually look much shorter, of course. It looks like you've just saved yourself one character, basically. But you'll notice that it has less duplication. And as your data structures get bigger or more nested, this gets more and more valuable, being able to do this, to just go straight in and grab the keys out. Anything else with map destructuring that's worth? Oh yeah, there is one more thing that you can do. You can do, if we do a let again, and let's do just like we did here with the keys, because that is really the main way that you will access maps or destructure maps. So let's do keys x, y, and z again. But you can also give a default value. Let's say that one of those values didn't exist, and let's say x. The default value for x is 100 this time, and the default value for y is 200. Okay, and instead of, let's move that there, and instead of passing in the original map, which does have x, y, and z, so okay, well let's start by passing in the original map. And let's add them up just to confirm that we're going to get the same result that we've gotten before. We get 60. But if instead of passing in my map, let's make a new map up on the spot, and let's say that it just has z of 50. So in this case, what we're hoping is going to happen is, because we've said or, is it will say, I don't actually have an x in there, so I'm going to grab it from this or map instead, and I don't have a y, so I'm going to grab it. So we should get 100 plus 200 plus 50, so this should equal 350, and it does. So that's a way you can do defaults if you're not certain if the data that you're getting in has the values that you're expecting. So that can be very useful. Okay, so that's how you do destructuring. What about when you do it? But even though in all of my examples I've actually done it during let binding, I actually find that when I'm writing real code, it's much more common that I use it in the arguments passed into a function. You can sometimes do it this way as well, and I have written code where it's a let. And the reason I chose let in the example is just because it's a much faster way of showing you and not having to define functions all the time. But let me show you a more realistic example. So let's say we had a really, not really, but a nested data structure. So let's just make up some kind of a nested data structure like, so let's have a vector, and the first element in the vector is a map. And the map has, let's say, a keyword A, a keyword B, but instead of B being just an integer, let's make that actually a vector, which has 2 values in it. And then let's say that C comes in and has a value. And then let's say that the second element in the vector also has a value. So we've got a really strange looking shape of data there. So let's define. So let's say we wanted to grab all those values out of that data structure. How could we do that with destructuring? And let's say we wanted to grab them all and add them together. So let's say we're trying to make a function that says add everything, nice. And we're passing in that element, that data structure. So now let's define that function, define add everything. And this is where you can use destructuring in the argument part of a function. So instead of just giving it a name, here we can give the shape of the data that we're passing in. And as we saw, it's the outside of the shape is a vector, and then the inside, the first element is a map. Lots of brackets, but bear with me. Okay, so we're going to use the keys trick that we used before, and we know that A and C, we can just grab those values directly, so let's do that. But B, we're going to have to do some nested destructuring. So all we need to do is describe the shape of B in the same way that we've described the shape of the overall data structure. And we know that B is a vector, and we know that we want to grab B1 and B2 because there are 2 values, but we need to tell it. We can't use the keys part of this because we're actually telling it the specific shape of B. So if you look back on this first one, how we gave it a name and said what the keyword was, what we're doing there is exactly the same, but instead of just giving it one name, we're zooming in again. We're going down one level, one inception level, if you like, if you've seen that movie, and we're assigning that data structure, that inner data structure, the names. So it's nested destructuring. Okay, so that should grab out A, B, and C. We've grabbed C's, and then we just need to grab out D, which is outside of, it's the second element in the vector basically. So now we've described the shape of the data, or of the data structure, and then we can use that to let's just add them all up. So let's just add A, B1, B2, C, and D. So let's define that, and then let's run it with this, and what should the result be? So 1 plus 2 plus 3 plus 4, 10 plus 5, 15, should be 15. And it is. And I think you're going to find yourself doing this quite often, that when you've got a known data shape, if you like, the shape of the data in your data structure coming in, and instead of just giving it, let's say that we just called this, let's cut that and call it data. Then, of course, the first thing you have to do is a big let binding where you're grabbing the first element out of it. And, you know, like we did at the beginning, it can be a lot of code. But you see how much more concise it is just having it as destructuring. So again, it's not giving you a superpower. It's not letting you do something that you can't do with other approaches. But what it is letting you do is do it very, very concisely. And that's why I think it's something well worth having in your Clojure toolkit. Great, that was a whistle-stop tour of destructuring in Clojure. I hope that you learned something from it. Thank you for watching. Bye-bye.